Welcome to Bruker Nano. My name is Roald Tagle and I'm the application scientist responsible for Micro-XRF here in our facility. Today, I would like to show you a brief introduction of what is Micro-XRF and what type of sample we can measure with Micro-XRF. Micro-XRF is a technique that combines the element sensitivity of the X-ray fluorescence with a spatial resolution given by a focused X-ray beam. This means that we can determine not just the composition of a sample, but just studied non-homogeneous sample. Most samples, as you see here on this table, are non-homogeneous. And we have different examples covering, like in this case, the geology, where you can measure with the focused X-ray the distribution of the different elements within the surface exposed to the measurement. We have the possibility to measure, like here, industrial samples where it's not only interesting to know the composition of the metal, but also what are the elements on the surface of the material. You have the possibility to determine, like in these drill cores, what are the proportion of the different mineral phases within this drill core sample. And one interesting thing of the Micro-XRF is that you do not just get information of the elements in the top layers of the sample, but also from the depth. Depending on the material, you can get to micrometers or millimeters inside of your sample. This allows a unique opportunity to study not just bulk materials, but also layer and coating thickness of different materials, like in this case, the gold coating on the surface. Another of the important things actually to point out for Micro-XRF is the non-destructive approach for sample analysis, which means we can just place the sample as they are into the machine and get information about the element distribution without requiring any previous preparation. We can use, like in this case, a fossil fish and determine what are the elements in the fossilized material without doing any additional preparation to the sample. Also, some of the sample is not possible to make any preparation, and actually you want to have it as the measurement as they are at the moment. We can determine the composition of the ink in the parchment or in the paper. Therefore, it's a technique which is quite interesting for forensic applications where the integrity of the sample after the measurement process is very important. On the table, we have a variety of applications, but just a small part of the sample we have measured over the last years. And I hope I could give you just a brief introduction or an idea that everything could be a sample that can be measured with X-ray fluorescence, and especially with partially resolved X-ray fluorescence. And after the measurement, you have on one side the data with the composition information of the sample, on the other side you have the sample as it was before.
Lighter, faster, deeper. You know, Micro-XRF is the method of choice for non-destructive, spatially resolved element analysis of diverse samples. Brilliant! But today, Bruker heralds a new era of Micro-XRF light element spectrometry. The M4 Tornado Plus is the world's first Micro-XRF spectrometer for high-resolution analysis down to carbon. Yes, carbon! Let's take a closer look at the M4 Tornado Plus. It is 10 times more sensitive than its predecessor, so it analyzes even light elements such as fluorine, oxygen, nitrogen, and carbon with unprecedented detection limits. With the newly developed patented aperture management system, the X-ray beam is narrower, meaning the instrument keeps more in focus with a higher depth of field. With the new pulse processor, it can measure twice as fast as any other Micro-XRF system. The innovative M4 Tornado Plus has a quick change stage and an optional specimen holder for drill cores and thin sections. This minimizes both the setup time and the sample exchange. To extend the range of application, even for vacuum-sensitive or hydrated specimens, the optional programmable helium purge system makes it possible to detect light elements at atmospheric pressure. The M4 Tornado Plus presents a giant leap in Micro-XRF. It opens up the possibilities for peerless analyses and quality checks from now on. Please contact us for further information.
Bruker is known worldwide as a leader in all forms of X-ray analysis equipment. From handheld XRF analyzers to large XRF and XRD analyzers. Bruker's Elemental Division, a technology leader in handheld XRF, manufactures a full range of instrumentation for use in elemental analysis. Bruker Elemental began in the early 1980s with a team of scientists from United Nuclear and the U.S. Department of Energy who pioneered early breakthroughs in portable XRF. The S1 Titan, Bruker's newest innovation, is among the lightest tube-based handheld XRF analyzers on the market today. Fast analysis speed and exceptional accuracy are two key attributes that help define the S1 Titan. Other features separating the S1 Titan from its competitors include our smart grade timing, sharp beam optimized X-ray geometry, and the X-Flash silicon drift detector. The S1 Titan features an intuitive graphical user interface and results presentation, which will have even a beginning user up and running in no time. Packed with the latest technology, the S1 Titan also offers numerous safety features and a state-of-the-art ergonomic design. For manufacturers, delivering a quality product is everything and requires vigilant testing and attention to detail. Positive material identification, PMI, is often a required part of a company's quality policy. Alloy identification may be lost as the metal moves through the shop. Using the portable alloy analyzer allows immediate confirmation and ensures that a part is the proper material prior to shipment to your customer. In the refinery or other industries requiring high temperature and high pressure, equipment safety is routinely ensured by alloy verification. Over 75% of refinery incidents are caused by having the wrong metal in service. By maintaining a strong PMI program based on API 578 or internal procedures, these failures can be virtually eliminated. Handheld XRF has become a standard tool in the metal recycling industry. The analysis provides elemental concentration, alloy identification, and scrap value. In foundry applications, XRF can also determine tramp element concentration. Versatility is just one of the S1 Titan strengths. Metal sorting is the most common recycling application, but it can also help with the recycling of several other materials. The S1 Titan can accurately determine precious metal content in recycled catalytic converters. In addition, the S1 Titan can be used to evaluate e-scrap as it moves through the recycling chain. To learn more about the S1 Titan or schedule an on-site demonstration, visit bruker.com/S1 Titan.
The S4T-Star is a unique total reflection X-ray fluorescence spectrometer. It is developed for ultra-trace element analysis in a broad range of application fields. The S4T-Star was specifically designed to meet the growing demand in increasingly regulated areas, such as the pharmaceutical production according to the new EU and US pharmacopoeia standards, new product development and quality control in the food industry, or control of contaminants in wastewater, slurries, and effluents. The S4T-Star uses up to 3 different excitation modes, the benefit for the user's ultimate sensitivity with the detection limits for most elements below 1 part per billion. The automatic sample changer is designed for multi-user operation with a total capacity of up to 10 sample trays, each holding up to 9 samples. Depending on the application, dedicated trays are available for different kinds of reflective sample carriers, such as quartz discs, microscope slides, or silicon wafers. This unique flexibility makes the S4T Star a most versatile tool for the analysis of a multitude of sample types. Type and position of tray is automatically detected and shown by a flashing blue LED light at the left side of the front panel. These LEDs also indicate the status of the measurements. Right side LEDs flashing means job running. Entire LED line constantly shining means job finished, the tray can be removed. A smart way of communication. The S4T Star is dedicated for continuous 24/7 multi-user operation in industrial routine analysis. Therefore, automated batch processing is supported as well as unattended operation, for example overnight. The user-friendly software helps to set up your measurement task quickly. Right after the measurements, quantitative data including statistical calculations and reports are created automatically. For quality control, the software also allows the definition of crucial thresholds or confidence limits and provides warnings if critical limits are exceeded. The S4T Star is the first T-XRF spectrometer that automatically runs quality check routines in the background, utilizing internal quality control samples to monitor and stabilize crucial system parameters. Analytical chemistry has never been easier with Bruker's S4T Star.